Good afternoon. Welcome to my presentation. Couple of seconds about myself. My name is Degioanni. I'm the founder and CEO of Sysdig, Inc., and the original creator of the open source tool called Sysdig. I've been involved with open source for most of my career at this point, more than 10 years. In the past, I've been involved with network monitoring tools like WinPickup and Wireshark. And thank you. It's funny how many people still know about these tools. Raise your hands if you think that containers suck. So either everybody's listening to me, let's try the opposite. Raise your hands if you think containers are great. All right, so you are listening to me. This is just a short list of the cool things that containers bring to us. I don't have to explain them to you, but faster deployments, reproducibility of environments, cost optimization, isolation, flexibility. The only problem is monitoring and troubleshooting containers, seeing inside containers is not trivial. Part of it is because it's a new emerging technology, so a lot of work is still being done around them. But part of it comes from their properties, right? So containers are isolated, self-contained, simple, lightweight. These are some of the nice properties that we like in containers. These properties also tend to make it harder to see what's happening inside them, so make your typical process of monitoring and troubleshooting quite harder. In particular, a question that, together with my team, we started wondering about is it possible to achieve and respect these properties that are listed on this page in a monitoring system? So is it possible to build a monitoring system that is isolated, self-contained, simple, and lightweight? This talk tries to address this question. In this talk, I'm going to go over some options that we have in terms of open source tools and command line tools to see what's happening inside containers. I'm going to talk, to spend some time on CAdvisor and then on Sysdig, which is the tool that we develop. I'm also going to give a CoreOS specific example or two. Most of my presentation is going to be hands-on, and I'm going to give demos and being in front of my console. So I'm really hoping the network connection will perform as expected, but don't worry, I have everything under control. Some of the things we would like to monitor. There's, of course, more than this, but for this presentation, I picked the list of things that would be nice to see for containers, and then I try to see what the current solutions are and what the state of the art is for these different groups. So resource usage, in particular CPU, memory and disk, network activity, so everything that has to do with sending data in and out of the network, file I/O, which is another important thing to keep an eye on, errors that are happening inside or outside containers, and maybe a bit of application activity. Let's start from resource usage. So we have a few options to see what's the resource usage of containers and processes running inside containers. First of all, we can run our traditional command line visibility tools from the command line, PS, stop, htop, and so on. For example, of course, the network connection is not working. Let's try again. All right. I can have top running, for example, on a CoreOS host. And one of the columns that I can pick, for example, is should be C groups. So if I do this, as you can see, now my rightmost column here is actually showing me the C groups of the different processes that are running on the machine. This gives me at least an indication if the process is running inside or outside the container, because you can see processes running inside the container from outside the container, because in practice, processes running outside the container are just regular processes running inside the machine, just running in their own specific namespace and using essentially their C groups for resource isolation. So at least top now, it's telling me quite clearly what's running inside or outside the container, because things with a dash here are things that are running on the main host, and things with a weird string here are running inside the container. Unfortunately, the only thing that top or htop or ps do is showing me the C groups, the full C group string that is running inside the machine. So that's the best visibility that I can get. Another thing that I can do, of course, is using the Docker tools. So Docker has a couple of command lines like ps to get the list of running containers, and then I can do a Docker top of one of the containers, for example, front end one. Docker top actually supports top syntax, so I can actually do a top command line to see the CPU usage for the processes inside that specific container. There's also in recent versions of Docker, a Docker stats interface, front end one, which is going to show me some resource utilization for that specific container. The Docker stats interface is quite new. It's nice because, as also mentioned in the previous talk, it also exports APIs. So from one point of view, you can consume it if you want to measure this stuff programmatically. And from the other point of view, there are tools that are starting consuming this API to offer visibility, to export these metrics and offer this kind of visibility. Limitations with Docker tools are, well, first of all, they only support Docker. So you're out of luck if you use other containerization technologies. And the other one is they're sort of limited and sort of shallow for the moment. Let's take a look at CAdvisor. Installing CAdvisor on CoreOS is actually pretty simple. It's just a container that you install with this command line. The command line actually tells you a bit of what CAdvisor does. As you can see, it tries to mount volumes, system volumes from the parent host operating system, and then publishes a user interface, a web interface on port 8080. So you just run this command line on a CoreOS instance, and what you get is something like this. Let's make it full screen. So first of all, as you can see, it gives you an overall view on the system, including network, memory, CPU usage, and so on, which is pretty similar to other monitoring tools that you can install on your Linux instance. What makes CAdvisor unique is that you have a list of containers. In this case, for example, I'm running a CoreOS machine with a few NGINX containers and the CAdvisor container that I just installed and the Ubuntu container. And I can go into any of them and start looking at metrics that are specific for this container. So this shows me the CPU for the container. This shows me the breakdown user and kernel, memory usage, and network throughput. So a nice user interface. It gives you, by default, a minute of granularity. The nice thing about CAdvisor is it supports an API, a bit like Docker stats, and it already supports some integrations. So I'm listing 2 or 3 that are the main ones, but essentially there's an API that can be consumed and then can be pumped to your monitoring backend, InfluxDB, Prometheus, Hipster, and so on. The main limitation with C-Advisor is essentially the metrics that you get are the ones that I showed you. There's a pretty strong limit on what you can get, and especially for a single container, essentially you're limited to this overall CPU usage, to the memory usage, and to the network bandwidth in and out, essentially. Let's talk a bit about Sysdig. Sysdig is an open source tool that we developed and we released around a year ago. We compare it to strace plus TCP dump plus LSOF with Lua scripts on top. Actually, I'm adding HTOP in the mix of these tools because we have developed a nice Curses UI that you can use inside terminals, and it's not officially released yet, but it's what I'm going to use it today for the demo, so that we have a bit more interactivity. The design goals behind Sysdig are make it production ready, have a very rich data set, so sort of filling the gap in terms of deep visibility inside containers, instant value, natural workflow, and first-class support for containers. So it doesn't happen very often in your life to have the luxury to start working on a completely new monitoring tool. So we decided why not having fun and starting working on containers right away, since we really love the technology and we're very fascinated about containers and the ecosystem around containers. How does Sysdig work? So this is a very simple diagram of applications and containers running on top of the Linux kernel, right? Each of them uses the kernel to interface with the hardware, and so the kernel sort of mediates between the processes and the container and the use of resources, system resources. The Sysdig instrumentation works by leveraging a little kernel module that is installed in the operating system, can be installed from the host or can be installed from a container. And at that point, through this module, it's possible to capture the interaction between each process or each container and the operating system, which means that then you can have a container running on the same host that consumes these events and offers essentially capture and analysis capabilities. We come from the networking space. We come from tools like TCP dump and Wireshark. So we designed a system that tries to capture the system events and packetize them in a way similar to what tools like TCP dump do, including being able to create trace files. And so decoupling you from having to be in front of a system when you have to observe the system and giving you the chance to take a capture and a trace file of the system. Let's take a look. So let's attach to the Sysdig container. And in the simplest possible form, Sysdig is actually not completely user-friendly. Actually, let's limit it to 1,000 events. So essentially what you're seeing here is what's happening inside your machine and what your processes are doing on your operating system. So writes events, read events, waits, selects, and so on. Let's use the PC command line that essentially allows you to instruct Sysdig to give you more fine-grained container functionality. So now we see the system events, but we actually see the container that is generating those events. And for each process, we actually see the internal and external process. Still not completely user-friendly, but we support, as I was saying before, both filtering and scripting on top of this. So I can do something like fd.port equal 80. Oops. And event.buffer contains get, actually, let's print it. So now, essentially what I've done is I created a filter that keeps only the events happening on file descriptors that are sockets and whose port is port 80. And I wanted only the events that contain a buffer, and this buffer contains the word get. So essentially I'm getting, as you can see, the HTTP requests that are coming to my machine. And again, I'm observing this from inside the container, but as you can notice, I'm seeing the traffic going into the other containers as well. So it's like visibility into containers running, for example, on your CoreOS host from outside the host itself. Still pretty technical and pretty low level. So let's go up one level. And one thing that we can do is running what we call cheesers. So containers.cpu. So cheesers are like scripts that you can put on top of this stream of events so that you can essentially synthesize them and have a bit more readable information. So here, for example, I'm looking at the CPU or, for example, the network traffic for the different containers that are on this machine. Let's go up one level, and let's, I was mentioning that we are building a user interface on top of this. So this is this interface. So probably if you are users as me of tools like HTOP, this interface is very familiar. We're looking at the processes running on this machine, with the difference that, again, we're seeing all the processes running on the machine from the container. Actually, let me do PC here too, so we have full details about these processes. So notice how we have the external PID of the process, the internal PID of the process, and then a bunch of CPU usage, file I/O, memory, and so on. Why internal and external PIDs are useful? That's because usually the internal PID is the one that you want to match to logs or stuff like that, because applications inside the containers know about their own internal PID. On the other hand, if you want to kill somebody from the external host, you need to match the internal PID to the external PID. Let's change views. So I can click on views. And for example, I can pick containers. And this is more like your typical cAdvisor view, in which you have the summary of containers running on the specific machine. The difference between these and something like cAdvisor is that I can change my selection and jump inside the container. For example, I can go inside my Ubuntu container. This one doesn't have connections, but if I look at the list of processes inside the container, now I have the list of processes that are running inside that specific container. Okay, so this gives you an overview of what Sysdig can do from the technology point of view. And again, we're seeing all of this stuff from one container that is isolated from all the other containers, but we see the whole activity of the machine. Viewing network activity. Again, cAdvisor. cAdvisor essentially gives us the network activity of containers just in terms of the total bytes that are generated by the container, similar for Docker stats. You can, of course, install iftop, tcpdump, tshark, or anything else inside the container that works and is supported. And you can take trace files, and then you can take them outside the container. I'm going to show you what you can do from Sysdig. So I can go back to the full system, and I can, for example, pick server ports. And here I can see that there's traffic on different ports. I can pick one specific one, which is port 80. This is the traffic for the whole machine, but I can click enter on it, and now I see the processes that are sending and receiving traffic on port 80. I can also go back and see at the network connections for the whole machine. So this is a bit like iftop, but again, I have container context, so I see which container is doing which connection. So it's a bit like iftop for all the containers on your machine. Of course, I can drill down into a specific container. So I go to the list of containers, and I pick one of my front-end containers. And I see the connections that that container is serving right now. And I can also look at the ports. And then, for example, dig into a specific port and look at the data that is exchanged on that specific port. Let me actually change the visualization. And these are the requests that are served by that specific container on that specific port. So quite a deep level of granularity that we can accomplish. Let's keep going. Disk activity. There's really not a lot of options that you have for disk activity to observe these activities inside containers now. So as far as I know, Sysdig is the only thing that you can use. Let me give you a couple of examples. One is I can go back to the whole machine and look at the directories that are accessed and that are generated traffic on that machine. As you can see, a lot of it is generated by cAdvisor, which is quite interesting because it also means that we can sort of try to explore what cAdvisor is doing to gather its own metrics. As you can see, it's scanning a lot of directories in sys or in var to extract essential information about network interfaces or Docker containers and so on. In fact, I can pick one directory and go inside and see which files cAdvisor is actually reading and writing in the directory. And again, I can look at what cAdvisor is actually reading and writing into the specific directory. This is useful, especially if you are trying to monitor, database I/O versus log I/O or problems like that. For example, if I go back to the whole machine, there's a view in Sysdig which is called container errors. And this essentially looks at all the I/O that is done by the different processes in the different containers. And it shows me the file, network, memory, container errors. And for example, I can see that my Ubuntu container is, my network connection is dead. Let's see if I can recover it. Yeah. The container is generating quite a constant number of file errors. So I can go inside that container, and I can see that these errors are inoent, which is essentially file not found error. One thing that I can do is looking at essentially the system call activity for the specific container, and I'm going to pause it. But I can see that the process is called myapp, generating this error. The error is happening when there's an open of a file, and this is the error that is returned, and the file error is logs /log1.txt. So this is a process inside the container that is generating errors because it's not able to open the log file. It's, again, as a reminder another time, we are able to do that from a separate container because we're capturing essentially the system calls that that specific container is doing and mapping them to error codes. Last thing that I want to show you before I run out of time is application activity. And to do this, I want to use an example I'm actually trying to attach to my other container, my other CoreOS instance, which is the one with the load balancer. Let's go into the Sysdig container. And what I want to do is I want to observe conf_d activity, which is something very common. If you use CoreOS extensively, conf_d is always working on the background. So very often, it might happen that you have misconfigurations or just issues, or you just want to see what's happening. So what I'm going to do is I'm running Sysdig, but this time with the command line filter that keeps only the activity for confd. So I have a nice clean view with just that process. And now what I'm going to do is I'm going to look at the activity of that container, and actually let's look at the activity as printable ASCII. Let's wait until confd should refresh every 10 seconds. Hopefully, there it is. And now, essentially, we have the full activity, both on disk and on the network, that confd has just done on this machine. So as you can see, it starts from a connection to port 4001, which is the etcd port. So confd is actually asking etcd for the list of keys for that machine. Then it's doing another request with a specific key. And then it's reading its template file. So haproxy.template file is read. It's brought into memory. The part that is interesting is this part, which is the part that confd is going to substitute into the file, the loop. Then confd is writing its modified configuration file to disk into haproxy.cfg, blah, 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 and so on. And we can see that it's writing the constant part and then having the loop down to write all the sections that are configured and modified. And then, the original file is read one more time for a diff. And then this time there's no difference, but otherwise, with an actual diff, we would see the file being written again and modified. So just an example of how you can leverage this kind of visibility to get specific CoreOS insights. One more thing that I want to show you is the kind of visualizations that we are putting on top of these, in our distributed software as a service tool. I think this is pretty interesting. So based on the same information that we're extracting through our instrumentation system, we're able to collect this information, bring it to a centralized point, so that it's possible to essentially have this kind of deep visibility, but in a distributed way, but also have visualizations of stuff like container dependencies. So this is the same infrastructure that I was showing in the previous part of my demo. Instead of being in the console, this time we are essentially in a JavaScript, in a browser in a JavaScript page. I can see that my front end tier here is made up of 3 machines. We can go inside and see what the 3 machines are. And if I keep zooming into a specific machine, now the machine explodes and I can see the Docker containers running inside the specific machine. So this is absolutely not trivial to do, because essentially you need to keep all the relationships across the specific containers, but I can keep going. And for example, I have all these WordPress containers inside the machine, and I zoom in and I can start Apache, I can start seeing Apache appearing. So this is an example of what you can do by observing container metrics and container activity from outside containers and just essentially leaving a delay underneath. I think I'm exactly out of time. So unless there are very quick questions, I would say thank you.